All right, let's keep going, everybody. We recognize this is an afternoon after you've been flying, after lunch, getting some exciting content here. And we have another one, data management, which is kind of like regulations and safety. It's not the most charismatic, exciting thing, but it's also important because, like safety, if you neglect your data management, you will pay the price, as many of us know. So for the next hour, we're going to introduce some of the ideas and principles and motivations and tools for working with drone data, because it's not trivial. All right. And as always, go ahead and if you have questions, please, we will pause for questions, but please raise your hand, or if you're online, please put something in the chat window. So this slide deck, which we will share at the end of today, has 7 sections. We're going to try to cover like 6 of these because we don't have time for everything. And yeah, but we'll go through this and we'll end with a little bit of a case study of how our group is trying to manage data, our drone data. Okay? We've made a lot of mistakes, but we've also made some progress on what we're doing. And we're a unit that does a lot of this, so we've had to deal with it. So why even do you want to think about this? So in short, drone data can quickly become big data, right? So it's probably intuitive that the amount of data as you measure it, maybe in megabytes or gigabytes, will certainly get larger as you work in larger areas. So as you're mapping larger areas, you need more imagery. That's clear, that's very intuitive. But on top of that, you know, if you're flying lower, you need more images for the same acre. If you're flying a 40 megapixel camera instead of a 20 or 12 megapixel camera, you're going to have larger files. If you're flying multispectral data, you're going to have, for every camera location, you're going to have like 4 or 5 TIFFs files, right? So that's going to, so all of this can quickly add up. If you're doing repeated flights, more, so some of those some of the small projects that we've done, small in project size, it's one of those cases where we've flown extremely low or repeated flights, but you can very quickly get a lot of data. And we're just talking here just about your primary images, the photos that come off the drone. They can quickly add up. This graphic kind of illustrates in broad terms how data, the amount of data that you have to deal with changes over your workflow. And of course, you know, when you're flying, you've collected, you know, maybe a few hundred gigabytes of data, but the photogrammetry piece of it, which we're going to do tomorrow, that's where the volume of your data really explodes. It can go up by a factor of 5 to 10 easily. A lot of that's those final products. There's also a lot of intermediate products, which you might be able to ditch at some point, but you need to keep them until you're through. And then if you're going to be doing analysis, what you get out of the photogrammetry are point clouds and a lot of high resolution rasters, orthomosaics and your elevation rasters. Depending what your goal is, you probably have to do some more work with those, maybe classify them, resample them, or something, feed them into a model. So by the end of all of this, the amount of data that you're getting can add up to quite a lot. And it's only when you've gotten through all of this that you have your final result, whether that's a publication or a management plan or something like that. And it's not just the volume of data, the amount of files you need to deal with. It's also the breadth and the diversity of the data that you're going to be working with. The images and those products from the stitching, those are definitely the big boys. But you probably have some flight logs, some GIS files. If you are doing GCPs to get higher absolute accuracy for your data, you're going to have to deal with those files. You have some ground sampling data. You might keep your telemetry files. Oftentimes, you might have other photos, not what you're going to stitch, but maybe a photo for your publication or your presentation or other types of photos. All of this stuff you need to kind of keep organized so you can find it again. and of course, all the process outputs. One I will highlight here are metadata files, right? So that's the data about the data, really useful for managing and cataloging your data. You may have to create some of that by scratch, you know, your README file where you type up some notes from your project. So it's a lot of different types of data that are also big. So that's the challenge. How are we going to manage all this stuff? So one option is to use one of the, I'm calling these the one-stop shop solutions, right? So all of these commercial companies, they handle this for you, or for the most part, they handle this for you. You design your missions on their app, on a mobile device. When the flight is done, you upload those images to their cloud computing platform. They do the stitching for you. Maybe they expose some settings for you. A couple hours later, you get an email saying your job is done. You go to the dashboard, you view it, maybe you share it with your client, maybe you can download the files, but they handle all the messy stuff, all the behind stuff. And you can go back to that same project 2 years later, it's all there for you, right? So this is a big appeal, and this is a reason why many people, if they have the budget and they're satisfied with the quality of the products, they turn to these solutions, right? And that's a good reason to use these products. They also take care of all the computations, which is another pain, as we're going to see. But you may not want to use one of those products. Maybe you don't have the budget for it. Maybe you need more dials and levers for your use case. So if you are going to go down the route of managing your own data, these are some of the requirements that you should think about, right? Storage, where are you actually going to store this stuff, right? On your desktop computer, on external hard drives, on the cloud, on a server, some combo of all those options. Organizing your data, that's not trivial, right? As you get more and more flights, more and more projects, organizing this stuff so that you can find it again, that your colleagues can find it again, this becomes really, really important. I think most of us have said, oh, let's go back to that flight, you know, that we flew 6 months ago, and reprocess this area. And if it's not organized, if it's all jumbled together, that can be quite torturous. Documentation, pretty important, certainly for your publication, for reproducibility, to let other people know that this data exists, that you've spent so much effort getting to. Formats, you've got raster files, you've got spatial data, you may have some proprietary GPS types of files and other stuff. Point clouds, there's different file formats that you need to be at least aware of that they're out there. Transferring data, it might just be you can drag and drop files from, using Windows Explorer from this drive to that drive. Maybe you have a network drive. It may not be that simple. If you're putting stuff on the cloud, or as we heard this morning, there's some places where internet's really slow, and dragging or uploading stuff via a browser, that may not cut it. So the mechanisms of physically transferring data might be something you have to get creative with. Privacy and security, depending what your project is, the data that you collect, you may have to be careful about who has access to it. That's not trivial if you're doing this on your own. The commercial platforms, that's another reason people like to use them, because they provide permissions and the ability to share data with specific people. How are you going to share your data? You're going to share everything, just the metadata, who is your audience, and then long-term backing up an archive. This is a big challenge for like the entire drone community. We're still working on that, at least in the academic world. Again, because these are large files. It's not free to store things, and if you want them discoverable, to be usable, you got to think about that stuff. So let me pause there for any preliminary questions or comments. Okay, so that's the need, right? That's what we have to work on. Yes. Yeah, the question that was raised is like, how do you decide what data to keep and what you can throw away? And Can anybody else relate to data hoarding and like backup 1, backup 2? A principle, we'll talk about this a little bit about how our group is doing, but one principle to certainly think about is that, you know, the images that come off your drone, that's your primary data. And anything else that you've collected in the field, GPS points, those are the jewels. Everything else you can reproduce, particularly if you're using a reproducible workflow. Like you're saving your logs from your GIS process. So you can ditch the intermediate projects. You probably want to keep your output, but the jewels that you absolutely have to keep are the primary data that are irreplaceable. Okay. Yeah, there's Hoarders television shows. They should do a Hoarders for scientists data. Yeah. All right. All right, let's talk about some general best practices for working with drones. So before you go to the field, some things to think about. Think about, you're probably going to be using memory cards in the field. I don't know of any drone sensor that isn't designed to store data on memory cards. Many cameras, they do have some internal memory. It's often maybe it's a backup, but in general, at least with all the sensors we've used, memory cards are part of that. So you need to be ready for that. I would propose that the gold standard for the number of cards to go to the field with would be 1 for every flight. That's not always viable, but if you are able to have enough cards that you don't have to reformat them in the field, the drone lands, you pull the card, maybe you copy it to your laptop to see how they look, and then you keep it in the case, and that's 1 copy of your data, right? So you can just keep them, and you can keep them on the cards until you have another copy, right? So the principle is you always want to have more than 1 copy of your primary data, right? That's not always possible, but it's something to aim for. A question we often get is like, what kinds of cards? The memory cards should I get? How big? Generally, the size of the capacity of storage of the micro SD cards is not a limiting factor. I don't know of any flight, even with very high resolution cameras, where you would probably need more than 32 gigabytes, which is a fairly modest memory card. I would rather have like 10 32 gigabyte SD cards than 3 or 4 256 cards, right? Again, so you'll have enough cards for more flights. So that's a general principle. And of course, you want to get good memory cards, not your 995, the lowest version that you have out there. Look for a reputable brand there's different standards for read-write speed. Get one of the faster ones that are designed for cameras, because it's not only reliability, but it's also, that camera in the drone is saving an image to that card like every 3 seconds, right? So you need something that can handle a fast read-write process. Other things to think about, being prepared for how you're going to manage your cards in the field. Yeah, so in my case, and many of us like these, you can get various memory card holders that can handle a lot of different cards. They're quite cheap, little spaces for labels. You can write there with a pencil, this was flight 1, this was flight 2, or whatever. Little plastic cases. I have a lot of Altoid boxes in my flight bag. But think about that, right? Because you're going to be juggling a bunch of cards in the field. All right, I'm seeing a question in chat. Once data have been backed and saved, do you recommend to delete and reuse the SD? Have certain SD cards already been formatted for one drone and other SD formats? Yes, we will cover that, but essentially, yes. So once you've copied the data off the card and you're ready to reuse that card, we just do quick format because that kind of resets everything on the card. It deletes any files. As you know, when you put a memory card in any camera or your phone, it generates, the system will create some files and folders kind of by default. So by reformatting, you knock all of that out, and it just takes like 15 seconds to reformat a big card. Yes. Has anyone heard whether formatting memory cards reduces their lifespan? I've not heard that, and I don't have any experience. Brandon.
Yes, it will reduce the lifespan, but most SD cards are rated for up to 10,000 operations. So if you're repeatedly deleting and loading up files, 10,000 files at a time, yes, that might reduce your lifespan. But you're more likely to lose your card before that.
All right, so Brandon just said that's true, but it's not a real limiting factor for drone operations because the cards still have lots and lots of write operations, even with formatting. Yes, other question.
No, just after that, there are also, talk about the quality of the SD card. There are some that are just rated for.
Okay. Okay, so that comment was also the cards, part of the specs they're rated for longer life expectancy. So you can use, and we have this Google Doc where we can maybe share some recommended cards if anybody would like to share the kinds of cards they use. We use a lot of SanDisk, but there's 3 or 4 pretty standard manufacturers out there. All right, let's keep going. Yeah, so think about how you're going to store your cards in the field, how you're going to manage them. And yeah, card capacity is not always a huge bottleneck. Okay, in the field. So now you've done all your preparations. Think about how you're going to manage your cards, right? So I will often take one on the drone, like maybe stick it on top of the water bottle or the back of the truck. But you think about how you're going to physically manage them. If you have helpers in your field, that's a nice task to give to somebody. Take this card, put it in the laptop, label it, put it somewhere. But just think about those logistics because we've all kind of gotten confused after you've got like 5 flights and then you've got all these cards lying around. How are you not going to mix them up? You may want to keep a log of your flights. That could just be a simple pen and paper log in a notebook. You could use an app or something like that. Again, this will help you when you get back to the office. It'll help you marry your data back to, in the units that you're going to use for processing them, and to maybe remember things about each specific flight, and to generate your flight metadata too, which we'll talk about. And all mission planning apps that we've seen, they all do give you the ability to save the flight plan, the missions. At a minimum, you can save them on the app. You may or may not have a little share button where you could sync that mission to the cloud and get it later, or email it to yourself, but at least you should save your flights. Again, that can help you later on when you're doing the processing. A pro tip, I would say, and this I say highlighted as a pro tip because we don't always do it, but really, really important. Review your images in the field. You don't want to get back to the office after you spent 6 hours out there flying and realize, oh, half the images in that flight were blurry and can't be used, or half of them were purplish and half of them are yellowish because we were using auto white balance and there was like big white areas of our study area. So this is really important, particularly when you're starting out a campaign, right? At least the first couple of flights of the day or the first couple of days of the week. It's really important to check your data in the field. So one option you can do is most of these flight apps, Pix4D, the DJI Pilot, and those apps, they do have the ability that when that drone is landed to copy the images from the drone to your device and look at them, right? That's a pretty standard capability of all the flight management apps. So that involves, that allows you to look at them and see if how they're looking. Some of these apps also simultaneously give you the option to upload your images to the cloud platform and start processing them. And that will tell you if it might be like a quick stitch kind of thing, and you might see that they are or are not stitching, but that'll also tell you if you have dropouts, which is another, that can be another issue. Like, half of your flight line, the images came back as 0 KB, or they just didn't get collected at all. That's not too uncommon. And then you can also look at them on your device. So we actually, in our group, we generally do not use the features of the apps themselves to copy the images to their, number one, that's usually they're trying to copy them to your device wirelessly, which consumes battery power. And we don't want to use the drone's battery copying images. We want to, sometimes like Pix4D, it'll even start transferring the images as the drone is still flying. I don't know if that takes a lot of power, but it seems unnecessary. It's also slow. It's much slower than like pulling the card and sticking it into a laptop with a card reader. So we generally don't use those options. But if you have the time and maybe you don't have, maybe you don't have a laptop in the field, consider that. But definitely you want to look at your images. Another option, which is generally what our group does, is that we physically copy the images from the cards to the laptop. Make sure you have the right kind of card reader. That's something else to check for. Ideally, when you do that, put the images into one folder per flight, again, to help you recreate and process your data when you're ready for that. So don't just like dump them all into one place. Doing a quick inspection of the images, they're going to be TIFFs or JPEGs probably. You can just look at them in Windows Explorer, see if they're blurry, right? That's probably one of the most common data quality issues. For some reason, they're just blurry. If you have a stitching software on your laptop in the field, whether that's WebODM or Pix4D Mapper or something like that, you can start a project. You don't have to do the whole thing. You can do a quick stitch, or you can just load the images into a new project and look at the camera locations. And again, it'll tell you if you have dropouts. All right. But do something in the field so you don't get home and get very sad because you have to go back out, which we've certainly done. Yes. Question. Yeah. So I'm using the words flight and mission simultaneously. Oh yeah. I see your question or point. Yeah. So if you don't finish a mission and you have to kind of like bring the drone home early because it didn't finish because your battery's getting low, and then send it out with another battery. It's up to you if you could, consider all that the same. One thing to note though, like when you put in a new card, which is recommended because you don't want the drone to fly away with your only copy of your data. It'll probably start using the same file names, and then you can have images from the same that you want to process all together, but they're all with the same file name. And then, so that would be a case where you would still have to use separate folders, even though they're like part of the same. You're going to process them all together, if that makes sense. Yeah, that's a good question. I guess the number one thing is please budget a little bit of time. Again, early in the day or the first day you're out there, maybe plan half a day just to make sure everything is working okay. Because all of this, it takes time. You can't drive out to your site and then fly from like 10 o'clock till 4 o'clock and get a flight in every 20 minutes if you need, unless and still do these checks, right? So give yourself some time, particularly as you're building experience. It's not just looking for images though. You need to plan time in the field. Certainly if you're doing GPS surveying for your ground control points, you gotta hike over your study area. It takes a few minutes to get the coordinates for your center point of your GCPs. Quite likely you might find issues that you have to troubleshoot, like your controller's not talking to the tablet, or there's a firmware upgrade, or something's often will not be working perfectly. All right, any questions? Okay, so back in the office, make a backup copy of your images as soon as you can. either on another storage device, maybe in the cloud, but at least get 2 copies there. We recommend, setting up a directory tree to help you keep all of your flights organized. So one folder for flight, but then those folders might be nested into the date that you're flying, or the location or the project. So we'll talk a little bit more about that, but put them into your directory structure as soon as you can. It'll just make your life easier. Avoid long path names. So we use we try to be consistent with abbreviations for a place or within a site, within a location, and so forth. That can help you create directories that don't have too many levels of depth, which is burdensome and can cause problems if it gets too long. Okay, questions about best practices, or anyone else have a general best practice for working with their data at any stage? Yes. The question was, or comment that it had some issues with the speed of the drone being too fast and taking images too quickly, close together, for the card to keep up with it. And this was an example of where they were saving the images as both RAW and JPEG. So RAW files are uncompressed, they're high quality, but they're ginormous, right? So that could be a cause for the card not being able to keep up. You can control the speed of the drone in your flight management app. We definitely do that. I certainly do that when I'm flying low, right? Because when you're flying low, the relative speed over the ground is, so you're more at risk of getting blurry images when you're flying low and fast. So I would certainly slow it down there. There may be some other use cases where you would need to slow down if you're using a rolling shutter camera. Again, that's where you might want to slow your drone down. Anyone else have comments about or experiences with a card not being able to keep up with the number of images per second or per minute? Yes. Okay, so for the people on Zoom, the conversation talking about one mitigation might be getting a faster card with a faster read-write speed. Flying higher might be another way where you can get, but then again, there's a compromise with your resolution. There's another question back here. Yeah, some of the apps have a mode where it will actually pause every camera position, so it doesn't move at all. It's stationary. That's going to dramatically extend the length of your mission and reduce the amount of time you have. So that could be a setting that you could use too, if you really need to save the RAW and JPEG images. Oh, that's good. Okay. Yeah, so for people on Zoom, another suggestion was to stagger the images. So you're doing like every other image and then do the flight line twice. Another question? Okay, yes, in the back. Okay, so that comment was there's different types of hard drive, even the little external portable hard drives. They can be solid state or the more traditional HD where it's the platter moving in. Recommendation is to get a solid state external hard drive. They tend to be more robust. But in general, look at the reviews for your external hard drives. If you're looking for something with field use, look for one that's kind of designed for field use, has a nice, good case and all that stuff. Yes. Per file. Does anyone have recommendations for sharing extremely large hyperspectral files? So for people on Zoom, some of the suggestions were like physically moving, like mailing somebody a memory card or something. We've certainly done that. Like sneaker net, I guess they used to call that, or using a transfer device like FTP, where it's kind of, it might take a while, but it's kind of like you start it off and it keeps going. Of course, you need a FTP server that can, resume broken transfers. There's another one that I forget the name of it, that research data. So I'll think of it. It's a third-party service, but it's designed for that. Yes, I saw a hand up over here. Oh yes, I'm sorry. There's one over here first, and then we'll come back. The question was, how do you get rid of the blur at the end of your survey when you're stitching those images? We're going to see that tomorrow, but in all of the stitching software, yes, you can. You expect worse quality stitching around the edges because there's just fewer images, so fewer look angles, and that tends to be blurry or splotchy. And yes, they all provide you a way to crop that out in your final product. Good question. Yes.
Yeah, there was a slide earlier that said RTK. Is it just that RTK doesn't quite give you that what you really want, or?
The question was about RTKs are not a substitute for ground control points with reference to absolute accuracy. So I'll pass the mic over to Brandon because he can share something.
Yeah, RTK is great. It's great for navigation, but there are, again, some use cases where the RTK information is not actually being passed along into the images themselves. So it's just being used for navigation and not for the image analysis. And then on top of that, the RTK is great for making sure that the alignment and the positioning of the picture taking is accurate, but may still drift over a time series. So you're talking about one week to the next week to the next week. It's not going to still allow for the perfect alignment of your map, especially if you're trying to align these 2 centimeter pixel sizes week to week to week. So for best use cases, definitely still use ground control points. Preferably try to keep your, if you can, have a permanent ground control point in one of your fields so that you can make sure you have your band-to-band alignment, especially for your time series. No, you can probably get away with less. So usually if I was doing non-RTK systems, I would run 10 ground control points per 100 pictures. But with an RTK, you could probably get away with as little as 3 per 100 or 150 pictures.
Thank you. And that might be another case where permanent ground control points might be worth investing in, because then you don't have to resample them every flight, and you can even do image-to-image rectification if you need to. Okay, let's keep going. These are great questions. Any other questions on this? All right, good. I love this, all this technical stuff. Okay, so next I'm going to hand it over to Shane, who will talk about some of the considerations for data storage.
Yeah, so we're going to talk about data storage. We're going to hit on local storage, server storage, and cloud storage, and the trade-offs between them. So the first one we're going to talk about is local file systems. In general, these are Windows, either Windows machines, Apple machines, or Linux. One caveat is if we're dealing with ArcGIS, Esri software, this does not exist, and this only exists on servers. So just a note on that. So think about storage on your own machine. You can have your computer hard drive or an external hard drive, and it's a really good system for at least having active data that you're going to be actively processing on your desktop. I would not recommend using cloud for cloud servers to save your data and work with it on your actual desktop. There's going to be very slow transmission of the data, and I don't even know if it would work in some cases. I will say though that servers do work. You can store your data on a server and access it with your desktops, but you're really at the mercy of your network speeds, and that can also cause your processes to run quite slow. So if you're going to be working with large data sets, a large number of images, do it locally, process it there, and then move it afterwards. One thing to think about is, in general, hard drives, external hard drives are cheap. You know, they don't cost that much to get a terabyte, 10 terabytes, 20 or a little more expensive. But in general, they're cheap. They're easy for you to manage. However, the caveat is it's difficult to share with others. And that kind of gets at your hyperspectral question and your large data questions, is in a lot of situations, you're not going to want to push that up to the cloud and have someone try to pull it off the cloud. You're going to drop it to a hard drive, ship it to someone. You're going to walk it across the campus. You're going to take it somewhere and hand it to someone physically, because it's going to be really hard to move drone data, especially processed drone data, because they're really large files. And I should note, it's also really easy to back your data up because it's all right there, and you can just drop it to a hard drive. Okay, servers, very similar. Windows, Linux. I think there's an Apple server. I think. I've never used it, never come across it, but I think there is a version of an Apple server. But in general, I think of Linux and I think of Windows. Once again, you're going to have a large storage device on the network that you have access to, and you can do your processing there. In general, servers are a little more expensive. Obviously, if you're buying a server for your group to share data, you have that expense, and the server is usually a pretty costly expense. They're relatively easy to manage. You can work with the data actively. They can be very secure. You can really control access to the data, sharing of the data among your collaborators within your organization. You do not always have the ability to share your data remotely or out to other colleagues not in your organization. And backups fairly easy. So I don't mind servers. One issue I have found is really the limitation on sharing with others. That's one issue I have with servers. Cloud file systems. You've all probably worked with cloud file systems, whether it be Google Drive, Dropbox, Box, or OneDrive, but they're not really good for active data. I know that there's Google File Stream. I have never, ever tried to work with data directly from Google File Stream. Theoretically, it might be possible, but it would be painfully slow. And I wouldn't recommend it even if it did work. So I try not to do processing on my local machine with cloud data. I would download it to my machine, process it there, and then push it back up. It's easy to manage small to medium data sets on the cloud server. It's not always easy to find data on a cloud server. How many of you have tried to go to Google Drive and find something? It's like you type in every keyword and tag you can think of until you find it. That's one issue with cloud servers. It's easy to share data with others. It's also easy for them to share data with others. So you really have to be careful of the permissions you give the people you share with, because that data can get out there more than what you anticipate. So you got to be careful there. And that gets into security and privacy. And I know varying educational institutions trust each one of these things to a differing degree. Not every campus, even in the UC, trusts Google Drive as much as Box, as much as Dropbox. They all have varying levels of how they trust these vendors. So just keep that in mind. Okay, so you have these data storage devices and you have your data. One thing you'll find is, I think some of you have mentioned, your data is already becoming a little unmanageable. It's getting large. You're getting huge data sets. In our organization, we have probably 70 or 80 projects. We've flown several hundred flights. So we have a ton of data. I'm not going to give you the exact amount, but it's a lot of data. So we ended up developing a structure that we could use to keep track of our data. This includes keeping as I think Andy, you referred to it as the jewels. So we kept the raw imagery. We kept the GCPs, all those type of items in one folder. We keep that data, we back that data up. We have another folder for the processing report so we can see how we did with that, as well as the finished GIS products. So the DTMs, the orthomosaics, GCPs, sometimes the last point clouds if we're generating those. But we keep the finished products and the initial products because we feel that we can always recreate if we have to, the final products. Also, the processing tools that these companies are developing are always being reworked and tweaked and improved. So at some point, you may want to go back and reprocess those jewels that you have and reproduce your final results. So you want to make sure you keep them. So we have a data structure built where we keep track of project and then the sub project. So let's say you're at the CSU Monterey Bay and you have a flight at the golf course. So you would have UCSB, then you would have golf course, and then you'd have the date of the flight. So you really try to keep really good regimented data structure. So it's easy not only for you to find your data, but also for people like Andy as a member of my team. So if I say, Andy, I need you to go out and reprocess Monterey Bay, he knows where to go and what to find. So it makes it easy for all your people in your team to work with it. So that's very important. Another thing is file naming standards. How many of you are GIS people right now? Okay. How many of you have file 1 shape, file 3 dot shape, file A, B, C, D, all those type of things? We all do it. I know the guy in the back who's the hoarder, he definitely does it. So the important thing is file naming standards. Have a set way you do your files so that you can find them. They're easy to find, easy to work with. You can also write code and programs against those files if you have this set structure that you can always depend on. So keep that in mind. Do not use special characters in your naming. Don't put at symbols, don't put ampersands, keep it really basic. Certain programs do not like spaces in names, whether it be in paths or file names. Use underscores. Keep your file name short. We're not limited to the old DOS construct of, I think it's 11 characters or 12 characters. It was 8 plus a period plus 3 others. We're not stuck to that anymore, luckily, but you don't want to get much more than 25, especially when you start dealing with directory structures. Your directory structure could be rather large, and Windows in particular has a real problem with path names and file names exceeding 255 characters. You can sometimes accidentally create them, but the minute you try to move them, copy them, or do anything with them, you just get error after error after error. So you be really careful on long file names. And just try to come up with a system of naming that everyone on your team agrees with. There's nothing more painful than having members of your team who deviate from this, and when you're trying to write programs against it, because it's always going to break your codes until they agree to work nice with you. So I'll leave it there. And it's not Andy I'm talking about, so you're good, Andy. Okay, so I'm going to leave it there for data right now for storage. Any questions on storage, naming conventions, directories? Yes.
I appreciate the direction of the directory for other data, like it's often recommended to put it into a relational database, so you don't have that included structure. Is there some direction for that with drone data, or is that not on the card?
I haven't seen anything particular about that. I know one of the reasons we came up with this structure. Sorry, the question was: is there a direction, or is the naming structure and the directory structure being standardized into more of a relational database? Relational data, right? Relational database.
Well, like, isn't the terminology for a database where you sort the pictures?
Oh, yeah. I think it depends. I do think it depends. So that was the question. And I think it depends on what you're dealing with. The reason we came up with this structure is because we do a lot of Pix4D processing. And Pix4D has this really long, convoluted data structure. And it was starting to become unmanageable with all of our projects. So we had to simplify that. But we haven't dealt much with databases and storing these data just because they're so large. We do some mosaic data sets with file geodatabases and enterprise databases and ArcGIS. So we have done that, but we still keep it in this underlying structure. I don't know if that answered your question.
Select by sort of year or date.
Yeah.
The best strategy for.
Yeah, so that's a really good question. So we do that in order for us to be able to select by date, year, things like that. We actually create a mosaic data set of these data, and we add additional fields to that table in the mosaic. So we can then write SQL expressions against that. So then we can have one data set and just say, give me everything from Hopland Rec on this month, and I only want multispectral Sequoia data, and it subsets it all down to that. So we do that, but we're not showing that here. And I could talk to you more about that if you wanted to. Okay, yeah, we could talk after this session. Okay, any other questions quickly? Okay. Am I on next still? Oh yeah, we're gonna skip this. You can look at this, it'll be in the slides. It's just common little things to think about, common gotchas when you're out in the field and when you get to the office. And I'm not gonna ask for questions. Sharing results.
Okay, so another part of data management is probably you're going to eventually want to share your work with others. That might be just modestly, maybe you're working on a publication, maybe some figures for there. That's one end of the spectrum, just the final product. At the other end of the spectrum, you might want to share the whole thing, your raw data, your scripts for reproducibility. And in between those two ends of the spectrum, there are like other types of things that you can share that are kind of intermediate. So sharing just the process data, right? That you've stitched together. Sharing maybe the existence of your data and your processing scripts if you're using a reproducible workflow. That might be something you want to share. At a minimum, I wish we would all be better about sharing our metadata, that sharing the existence of our data that we have. So much is invested in getting good drone data, and the vast majority of it is just dark. It's on people's drives. Maybe there's something in a publication, but this is data that's irreplaceable. And there's so many questions in science about phonology changes and training machine learning algorithms. And I think that's a collective challenge I would put out there. Is finding better ways to share the existence of our data. Web maps, that's another kind of way that you can share some of your data. So that's step one. Think about what do I want to share? And work towards that. These are some of the tools that you can share. Most of these on this side are commercial platforms. I will give a shout out to Open Aerial Map. This is a open source platform that's open to everybody. It is web-based. It's from the same people who developed OpenStreetMap. And you can use it to share your data. Either you can upload your process data. I don't think you can share like lots of, your photos, but you can certainly share a URL that takes someone to where your photos are and maybe your email address to get more information. It's a nice platform. It was very much developed for drone users and people who are working with image data, maybe, other aerial data. Some people also sharing satellite images there. DroneDB is another newish kind of platform. I just learned about that this week, so I'm going to be looking into that as well. But that's another open source platform that's being developed to help people share their drone data. So really excited about that. If you are working in an academic setting, Dryad, they're all about publishing data sets, and your university needs to subscribe to that, but that's a good tool if you're doing research work. Creating catalogs of your data. That's one way to share data. I don't know, there's not many good tools out there that will do this. I wrote this R package. I had a poster on it yesterday. I'd be happy to talk with people, but the primary reason I wrote it was to generate these like plain HTML files. You can just upload them to any Apache, Linux server, and they combine flight metadata with an interactive map. Half of the metadata that appears is being pulled out of the images. The other half is being pulled out of flight metadata files, which is like, the name of the project, the name of the aircraft that you were flying, because a lot of that stuff is not saved as part of the images. And it's only designed to share the existence of your primary data. We use this for ourselves because I would like to go back and say, did I actually fly this area? I can pull up the flight summary page and take a quick look. Anyway, so that's an example of a tool. I would argue that the gold standard that we as a community should be aiming towards are going to be fair and reproducible. So FAIR stands for findable, accessible, interoperable, and reusable. This is a standard as we are moving into a world of big data, and there's lots of data. Scientists around the world are recognizing the challenges of that. So this is kind of a set of goalposts to aim for. Some funding agencies are requiring recipients of grants to do some of these steps in their data management plan. The EU is much further along than the US, but even US agencies are taking this seriously now. Repeatability or reproducibility. This is where, it's another gold standard for science, right? For computational science, where part of science is your experiment, your work should be, at least in theory, reproducible, right? Which is not necessarily trivial with point and click operations. Metashape is one of the programs that it's used. We're not teaching it this year, but it has a Python interface, and that's available out of the box. Pix4D has something like that too, but it's another license you have to get. Okay, so that's getting. This is the button I hope in a few years from now we're going to see in the in Pix4D Mapper and Drone Deploy and SiteScan. I hope the manufacturers of these programs will get on board and put a share button there, so at a minimum, the existence of your data can be published somewhere for others to find. All right. And with that, but there is some progress to make, and Esri, I think, deserves a bit of credit. They've invested heavily in drone tools in the last couple of years, and Shane's going to talk about some of what they offer.
Thank you, Andy. Yeah, so I am the, oh, yes.
You absolutely can submit your images to Dryad, and I think that's your choice as the researcher. You can also it's going to be, but it's designed for large data sets. Yeah, if you're talking like hundreds of terabytes, maybe not, but yeah, those are or at a minimum, your metadata, and then a way for someone to contact you to get access to the primary data.
Long-term now are suggesting that is not acceptable.
Dryad is not acceptable, or metadata is not?
Email the author.
Okay.
I get behind that.
Yeah, that's good to hear. I mean, I would support that. As scientists, one of our products is our data. The UC system has a site-wide subscription to Dryad. I know about that. There's the California Digital Library. They can publish data sets of a certain size, but it's a challenge because it costs money to host data for forever. And that's kind of what we're hoping. So maybe we can do a breakout group on Thursday on some of this sort of, if there's enough interest.
Okay, so we're going to delve into the ArcGIS ecosystem a little bit. My specialty is GIS and using the Esri system. So this is why I'm handling this section. And we're going to quickly talk a little bit about how ArcGIS Pro, how you can share data and products from ArcGIS Pro. And then we're going to hit on a little bit of ArcGIS Online and some of the extensions they have recently come out with regarding sharing data. We're also going to touch on ArcGIS Server and briefly on the new site scan. How many here have used ArcGIS Pro to date? Okay, fair number. So then you know that in ArcGIS Pro, you can go to the ribbon and you can find the sharing ribbon. And on the sharing ribbon, you have the ability to share map packages, actually project packages themselves. You can actually package up all your maps, data, layouts into basically a renamed zip file. And you can save that on your computer, or you can push that up to ArcGIS Online directly and share that link with your organization or just the general public. And they can get access to your maps and bring it into ArcGIS Pro on their side and open it up and use and work with the tools. So it's really nice in that way. They also give you the option just to share the maps themselves. You can share the map and the underlying data that's on a map, and you can do the same thing with layouts. And there's also a feature that I haven't used much, which is the mobile map. You can actually share it as a mobile map package that you can open in their in their mobile apps from Esri on your phone and use those data out in the field. Kind of familiar to similar to Avenza and things like that. Yes. I wouldn't use mobile map for that. I would actually push the data up as a web map and then have it save it as a hosted feature layer. And then you could use that inside of field apps. So, and one thing I have used recently, and this is fairly recently, is deep learning tools. I'm just going to add this real quick. You can generate a deep learning model using your rasters, push those up to ArcGIS Online, and then your colleagues can actually use your models to infer from those models that you've developed. It's really quite cool. Okay, so beyond sharing packages, you can actually share your data directly to the web into interactive web maps, also as web layers. If you try to share rasters though, using this tool, what's going to happen is going to create a tiled raster layer, and it's going to be treated basically like a base map. So you're not going to be able to do analysis with that layer if you share it as a web map, or even sometimes when you share it as a web layer. So that may not be what you want to do, and we'll discuss how to get around that. Beyond that, you know, as you could expect, you can share project templates, you can save things as map files, as layer files, you can always print maps. And I will tell you, they have finally, after 30 years, fixed the issue with transparency and layouts. That was an issue that's plagued them forever. And you can export to many different file types. So they've made vast improvements. So beyond ArcGIS Pro, this gets at sharing your data, especially drone data, is you can push your data from ArcGIS Pro and you can publish them onto an image server if you have ArcGIS Server set up within your own networks. So you can push that up as pixel level image services, which means that you can actually use these pixel services inside of ArcGIS Pro or in ArcGIS Online or as a web coverage service from OGC and use it in your client and actually do analysis on those pixels. You could actually use that to calculate, you know, NDVI. You could use it to calculate other indices. You can actually download the original or the output sets to your computer and work with them. So an image server is one way to actually share your data and make it accessible to others. And this can also be referenced in ArcGIS Online, and you can set permissions and privacy and make it accessible even more through their Living Atlas and other places. So it's actually a really nice feature. So beyond image services, they just came out with a new capability within the last 6 months. We've been testing it right now, which allows you, remember how I said you could share to ArcGIS Online, but it would come through as just basically a map, a base map in your map. They now have an extension you can opt into by giving them money. And what they'll do is turn on the ability to do raster analytics and store rasters directly in ArcGIS Online. Before this, you could have a map tile layer and you could do all these different vector analyses. But now you can actually store your raster drone data. Here's an example of the Lynn Cove wreck. And you can see that you now have raster analytics that you can do based on that layer. It's actually really quite powerful, and we are just slowly starting to figure it out. So this is something that's going to be, they're actually working, if you're in the academic field right now, and you're in college or university, they're trying to figure out how to build this into all of our master license agreements and make it reasonable. Right now, it's not necessarily reasonable pricing wise, and they're trying to make it so that we as an academic group would use it. So that's something that's coming soon. The other thing I want to talk about, and this is going to be really quick, is ArcGIS Site Scan. For those of you who were familiar with 3DR Tower, I don't know if you were or not, it was an old app, mission planning app. Esri bought it years ago, and they have continued to build on it and add new functionality and features to it. And it's been rebranded ArcGIS Site Scan. Site Scan is available. You can buy into it, and their licenses are based on the number of photos that you submit to be processed. It's I want to say it's like 25. It's like 25 gigapixel, and I can't remember how they define a gigapixel, but gigapixels, and you can have up to 100 users or more, but it's just the number of images that you submit for processing is what they bill you on. One thing I really like about it is the mobile app they have is really user friendly. It can do terrain following. You can create your missions in the app itself online, push it up to the mobile app. You can download it, you can modify it, fly it, and push it up. You can also have members of your community who are in this group also go fly those missions for you. So it really opens it up to the whole team. Another really nice thing is the enterprise fleet management functionality. It keeps tracks of your drones. It keeps track of your batteries, how many times your batteries have been used, how many flights your drones have, all that type of information that we're asked to keep. It keeps track of it for you. So it's really nice in that way. And also any of the imagery and products you produce, whether it be the LAST data, the DTMs, DSM, orthomosaics, can easily be published to ArcGIS Online and shared with the public, to your organization, groups, or just to yourself. So they've really tried to make it interact with their entire system, and it's all flowing through this one app. So it's really quite nice. As you can tell, I like Esri. I also like open source. I got to say that too. Okay, so that was ArcGIS in a nutshell. You're going to learn some of this tomorrow if you come to the UAV stitching UAV imagery with ArcGIS Pro. You'll also learn some of these things if you come to the ArcGIS mapping and data analysis class as well tomorrow. So we'll leave it there. Any questions? Andy? Oh, drone to map. Good question. So we were going to have a brief thing on drone to map and talk more about it. What we have heard recently is they're going to be phasing drone to map out within the next couple of years. So, and they're putting their effort into ArcGIS, into site scan and into the UAV processing right inside of ArcGIS Pro. So we're not doing anything on drone to map right now. Okay. Yes. There are many trade-offs. The first major trade-off is cost. If you're not part of the university or a college, academic institution, the cost is quite high. So that's one. If you just want to talk about functionality in ArcGIS Site Scan, one of the things we've noticed is we've had issues with multispectral data. It does really good job at, with RGB. We've had differing results with multispectral, and we haven't found a way yet to calibrate do spectral calibration with the site scan software. So there are some definite cons in that. Anything else? Yes.
The question on does site scan work like geocoding or
Site scan, good question. The question is, does site scan work like geocoding and use credits? No, because it's separate from ArcGIS Online in their credit system. What it uses instead is you buy a subscription for a certain number of images that you're going to process. And once you exceed that, I don't know if it automatically purchases more or if it just shuts it off and it tells you you have to buy more processing. So I'm not sure. We haven't gotten to that point yet. Yes. Ooh. Yeah, so the sharing deep learning part. So with ArcGIS Pro, you have the ability to run and develop your own custom deep learning algorithms. So you can develop that using ArcGIS Pro, and then you can share that deep learning model itself up, and that's what you're sharing. So you can create your custom models to extract, let's say, citrus trees in the Central Valley, or gravel roads in Northern California. You can have very specific things that you're writing for, and then you can share it with your organization or others. Okay, thank you. Any other questions? Next, Andy.
All right. We're in the home stretch here. So lastly, we'll just do a little case study of how our group organizes it. You've heard bits and pieces recently. So this is a diagram we made for like internal use. So don't worry, I'm just gonna highlight some of it though, like how we manage our drone data. It starts with a physical transfer of images from a drone to a laptop in the field via a memory card. That is standard practice for us. Another thing to highlight is that we do have a file structure. You saw a picture of it recently. We set that up from the get-go as soon as we can. And when we transfer the images to the laptop, we try to have that tree ready to go, or at least close to being final. Something else that we do, look over here. Oh, we do look at our data in the field. Best practice, right? And partly because we've learned painful lessons about not doing that. So we do look at the data in the field. We generally will certainly look at the quality of the images for, quick see if they're blurry, and then we will often start a project in the field to see if there's dropouts. That's something else we do. The next piece of it is we take the core data folder, which is primarily the images, and transfer it to beefy desktop computers. So we still, although recently we've started using cloud processing with SiteScan, but our bread and butter is working on Alienwares. That's a big gaming desktop, lots of powerful GPUs, and that's primarily where we process most of our data. So things that get moved over there, that's where we do the processing. We primarily use Pix4D capture, and it generates a lot of intermediate files and a lot of outputs. The outputs that we generate are determined based on the project. Like, do we need a elevation? We don't usually do the mesh, but again, it depends on the project. All right, so at some point there, we will also make copies of both the primary data as well as the products coming out of the stitching onto a big beefy external hard drive, which lives next to the Alienware, right? So that's one of our that's like the backup for the active data projects, right? It's not long-term storage. But then for long-term storage, we do differentiate what we label or consider to be core, important files that we do want to keep for the long term, as well as intermediate products that we can dispense of after, when the project is wrapped up, right? So we make that distinction about what we want to keep, what we don't. A lot of it's based on what can be reproduced, what can't. We often use cloud storage systems. We're not super sophisticated here. We're basically using Google Drive because it's available to us for free. But we will sometimes use this to transfer data from one machine to another. and we set up the Google Drive sync. So you just move a bunch of images in the Google Drive sync. It might take all night to sync up to the cloud, but simultaneously it's syncing back down to another machine. So we're logged into the same Google account on 2 different machines. And we also, so that transfers the data, and then we also have a backup on the cloud. We typically will hand over the data to the client, who are generally faculty or other kinds of researchers. At the end of the day, all of our projects, we put them on servers that Shane has managed and put together. And again, because we're an organization that's academic and we have a responsibility to keep our data available, everything is, at least in theory, accessible through ArcGIS portal, right? Which is one of the ways you can serve GIS data. All right. So that's, in a nutshell, that's what we do. And I won't go into the details here, but we do identify what can we get rid of when we're done with the project, and what do we want to keep in the long term on that server. So yeah, so those principles might be helpful for others. So I think we shall stop there. Let's take a stretch break. Brandon has a nice little presentation about exploding batteries, which I think you'll enjoy. And then we do want to end as close to 5 as possible, so people have an opportunity to go out and watch final flight of the day, which will be an autonomous mission. All right, so let's take a 5-minute break, and then we'll come back for roughly 25 minutes, half an hour, and then we'll be done for the day.